Hello and welcome to another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler and today we're going to be doing Unit 9, Lesson 3 on angle types and pairs. Now in the last lesson we talked about angles, and if you didn't kind of see that lesson or you're not comfortable with how to name angles, what angles represent, etc., make sure to go back and watch it. Now some basics, right? Angles are simply two rays that share a common starting point. That's it. And we call that starting point the vertex of the angle. When we measure an angle, we're literally measuring how much we would need to rotate one of the rays so that it fell on top of the other ray. And we do that by putting the vertex at the center of a circle, marking that circle off into 360 equal parts, and then we use those parts called degrees to measure how much we would have to rotate one ray so that it lied on top of another. Angles are very, very important in the real world because they indicate things like direction, right? North, south, east, west, stuff like that. And how much we rotate one to get to the other is also quite important. So let's start talking about different types of angle types. Now, angles can have any measure between 0 and 360 degrees, although for our course, we're only really going to consider angles from 0 to 180 degrees. What's really important is if you take 360 degrees, think about taking the number 36 and dividing it by 4, quartering it, right? 36 divided by 4 is 9. 360 divided by 4 is 90. Not 9, but 90. So a quarter of a turn is 90 degrees. And we almost always classify angles, the type of angle we have, by how it measures relative to a 90 degree or a quarter turn angle. So let's talk about some important angle types. One type of angle that's extremely important, not a surprise, is what's known as a right angle, and it's one that measures exactly 90 degrees. Now, two rays or lines that create right angles, 90-degree angles, are known as perpendicular to one another. It's a very, very important word. It's going to come up in a lot of the geometry problems that we have. Perpendicular means that two lines or two rays or even two line segments form a 90-degree angle. Now, an acute angle is one that simply measures less than a quarter of a rotation, right? It's one that measures less than 90 degrees. Acute literally means in Latin sharp. So an acute angle is one that kind of is a sharp angle. Then you've got angles that measure larger than 90 degrees, but still less than 180 degrees. These are what are known as obtuse angles, and obtuse literally means dull. In fact, another use of the word obtuse is if somebody is like, I don't know, a little bit like sleepy or groggy or a little bit slow to catch on to something, we might call them obtuse. Just a crossover term, right? And again, an obtuse angle is simply one that's larger than a 90-degree angle, larger than a quarter of a turn, all right, but not quite a 180-degree angle. A straight angle is one that measures exactly 180 degrees. Now, what's weird about straight angles is that you literally can't really tell the difference between a straight angle and a straight line. That's in fact why it's called a straight angle, because 180 degrees, right, it would literally be, well, you know, a half of a full rotation, which means that one side of the line would rotate on top of the other side of the line. Now we can kind of have a nice picture of these. Let me kind of bring this up a little bit so you can see it, right? A right angle, right? Those are extremely important, right? They show up in things like rectangles and squares, right? Then you've got an acute angle. This one measures 60 degrees. And again, you can tell how that angle, it would take less to rotate that ray into that one than it would that one into that one. And it's a sharper angle, right? If I had a knife or something, I'd want this to be the tip more than this, and certainly more than this. This is an obtuse angle, right? This is one that measures 105 degrees, more than the 90 degrees, right? It would take us farther to rotate that. And finally, a straight angle, right? And again, the idea is if I sort of took this ray and I rotated it over, it would take a half turn or 180 degrees for it to lie on top of that one. And yet, if I just gave you this picture without the words or anything like that, and I said, what is that? I hope you'd just tell me it was a line, right? Not so much of an angle as a line. But still, if we were to measure it as an angle, we would measure it as 180 degrees. So let's work a little bit with these angle types in first exercise. Let's take a look. Exercise number 1. Given the diagram below, name an angle that is A, a right angle, B, an acute angle, C, an obtuse angle, and D, a straight angle. All right, so one thing I really probably should have mentioned in this problem was that PM, or ray MP, is perpendicular to line RN. All right, I really should have mentioned that in this problem, that I've got this perpendicular to this. So let's just assume that for the time being. So what I'd like you to do right now is pause the video and see if you can name a right angle. And side note, there's actually two right angles in this picture. I'll name them both, but why don't you just try to name one of them? And yes, every angle you're going to have to use the 3-letter naming system, because every angle we're going to name has M as its vertex. So pause the video now and give me a right angle. All right, right angles are shown with a special symbol in mathematics, and it basically is shown with a little square. There's a right angle there, and there's also a right angle here. So you could have named the following right angle. You could have named the one that it would take to rotate ray MR up to ray MP, or vice versa, and that would be angle RMP. All right, that would be this particular right angle over here. Or you could have named the right angle over here, and that would be angle PMN. All right, keep in mind, right, that the M has to be the second letter, but you could have said angle PMR or angle NMP as well. Let's talk about acute angles in letter B. Now, there are two acute angles up in this picture. I'd like you to name either one of them. Pause the video now. All right, well, we have one acute angle that's created by the ray MR and MQ. We have another acute angle that's created by the ray MQ and MP. Either one of those would be fine. All right, so I'm going to start with angle RMQ, but I'm also going to list angle QMP. You only really have to list one of them according to the directions of the problem, but there are two. Now, an obtuse angle. There really truly is only one obtuse angle in this picture, an angle that is larger than 90 degrees, but isn't 180 degrees. So pause the video now and name the obtuse angle. All right, well, the only obtuse angle in the picture is the one that's created by ray MN and ray MQ. And therefore, that is angle QMN. And finally, a straight angle. There's only one straight angle in this picture. Go ahead and name that one. All right, well, that's the angle created by ray MR and ray MN. So that is angle RMN. And again, notice, every single one of these angles has letter M, or point M, as the second letter listed, because that's its vertex. You can't name any of these angles with a single letter because all of them have that same vertex. All right, so we've got acute angles, angles that are less than 90, right angles, angles exactly equal to 90, and obtuse angles, angles greater than 90, and of course the really weird ones, straight angles, angles that look like straight lines, right? Doesn't that look like a straight line, RMN? Because it is, you know, but it's also considered an angle. All right, let's keep moving. Let's see what else we have. Now, geometry problems can oftentimes combine elements of algebra along with elements of geometry, all right? And you have to be comfortable with both. So let's see how that's done in exercise 2, and then maybe we'll have you work exercise 3 on your own. But first, let's take a look at exercise number 2. It is known that the measure of angle C is given by the expression 4x minus 6. If x equals 25, then what type of angle is angle C? Explain or show how you found your answer. All right, so let's talk about something. Last lesson, we did talk about the measures of angles, but I want to kind of like mention something that I should have emphasized in that lesson, and I really didn't much, right? You've got angle C, right? And then you've got the measure of angle C. And they're slightly different things, right? Angle C is actually a collection of two rays, so it's a collection of infinite points. The measure of angle C is actually like its degree measure. So when they tell me that the measure of angle C is given by the expression 4x minus 6, I should write it down like this. I shouldn't really write it down like this. That's bad form. I really shouldn't do this. That's not good. All right. So I'm gonna get rid of that. All right. Now, what did they tell me? They told me that the value of x is 25. So I can actually figure out what the measure of angle C is by substituting 25 into that algebraic expression. Now 4 times 25 is 100, which I'm sure you know. Minus 6 gives me 94 degrees. So based on this, what type of angle is angle C? Is it acute, right, obtuse, or straight? Which one is it? Well, it's obtuse, right? Because an obtuse angle is any angle that is larger than 90 degrees, but less than 180 degrees. So we're talking about an obtuse, because larger than 90 degrees. And I really should say larger than 90 degrees, but not 180 degrees. All right. Now, let's take a look at exercise number 3. If angle A is a right angle, and the measure of angle A equals 8x plus 2, then what is the value of x? Solve algebraically and show your steps. All right, awesome. Well, I'd like you to pause the video right now and see if you can figure out the answer to exercise number 3. All right, well first, let's see what the problem really tells us, right? It says angle A is a right angle. Now, forget about everything else in the problem. Angle A is a right angle. What does that tell us? Well, it tells us that the measure of angle A must be equal to 90 degrees, right? We know that. But the problem also tells us that the measure of angle A is equal to 8x plus 2, right? Well, if the measure of angle A is 90 and the measure of angle A is 8x plus 2, then we can write down the following formula. 8x plus 2 is equal to 90, right? And once we have this equation written down, then we don't really worry about the geometry anymore. We just need to solve a two-step equation, right? And of course, the way we solve this two-step equation is the way we solve many two-step equations, right? I look at the left-hand side, I say, well, x was multiplied by 8, and then we had 2 added. So to get x all by itself, to isolate the x, I'm going to subtract 2 from both sides. That's going to give me 8x is equal to 88. And then I'm going to divide both sides by 8. And that's going to give me x is equal to 11. There we go, right? Simple as that. Now, what does this problem really do? You know, let's lay it out actually. This problem really forces you to know both your geometry, i.e. what does it mean for A to be a right angle? Oh, it means it must be equal to 90 degrees, right? And then how do I solve a two-step equation? Oh, subtract and then divide, right? So 2 very distinctly different skills. One of them, your knowledge of geometry. The other one, your ability to use algebra to solve an equation. We'll see a lot more of that in this unit. Let's keep going on. Now, angles sometimes pair up with one another in ways that are important. Each type of angle pair is given its own special name. I want to bring these up to the top so that we can really take a look at them. One of the most important types of angle pairs are what are called adjacent angles. Now, the word adjacent is one that you'll see a lot, not just in math, but actually everywhere in the world. Adjacent literally means sitting next to or close to or something like that. Now, when it comes to adjacent angles, 2 angles are adjacent if they share a common ray. They literally look like they're kind of sitting side by side, okay? So adjacent angles are like 2 angles that are sitting side by side and they share a common ray. Now, 2 other types of angle pairs that are important are complementary and supplementary angles. Complementary angles are 2 angles whose measures add up or sum to 90 degrees, meaning that if you put them side by side, if they were sitting adjacent to each other, they'd form a right angle. Supplementary angles, on the other hand, are two angles whose measures add up to 180 degrees, which means that if you had two supplementary angles that were adjacent, sitting side by side, they would form a straight angle. Okay? Now, don't get me wrong, complementary and supplementary angles don't have to be sitting side by side. They don't have to be adjacent. Any two angles that add up to 90 degrees are complementary, and any two angles that add up to 180 degrees are supplementary. But visually speaking, when put adjacent to each other, complementary angles would form a 90-degree angle, supplementary angles would form a straight angle. All right, so let's take a look at exercise number 4. In the diagram shown below, points A, B, and C fall along a line, and ray BD is perpendicular to line AC. Let's pop out just for a moment and talk about something, right? We saw this term just one other time today, perpendicular. BD is perpendicular to line AC. That means BD and AC form right angles. They form 90-degree angles. All right, let me just maybe even write this on your sheet. Form 90-degree angles. Very important. All right. So let's take a look at letter A. Letter A says, state the names of two right angles and explain how you know that they are right angles. All right. So why don't you go ahead and look at this diagram and give me the names of two right angles, and then let's talk about why you know they're right angles. Well, one right angle is the angle formed by ray BA and ray BD, so that's going to be angle ABD, right? And the other right angle is the one formed by ray BD and ray BC, and that is going to be angle DBC. Now, why do we know they're right angles? Well, I kind of gave the spoiler on that one already, right? But we know they're right angles because BD is perpendicular to AC. And let me replace that red with a little blue. All right, yeah. So in other words, because we're told that we've got a ray that's perpendicular to a line, we know we've got right angles. All right, let's take a look at letter B. State two angles that are adjacent and state the ray that they share. All right, so I'd like a pair of adjacent angles here. And I'll be honest, there's a lot of pairs of adjacent angles, like big time pairs of adjacent angles. And I just want you to state two angles that are adjacent. And of course, adjacent angles share a ray. All right, so you've got lots of choices here. I'd like you to pause the video, right? And you can almost like pick one of the rays, right? And say, all right, well, what are two angles that share this ray? And then they're gonna be adjacent angles. But we'll talk about a variety of pairs of adjacent angles in a moment. Pause the video now and go for it. All right, well, one pair of adjacent angles would be angle ABE and angle DBE, right? Because they share ray BE. So let's write those down, okay? Let me just change that back to blue. So we've got angle ABE and angle EBD, and they share, sorry, not enough room here, they share ray BE. All right, so that's one pair, and I think that's a pretty obvious pair. By the way, there's another pair of adjacent angles that share ray BE, and that would be ABE and EBC. So angle ABE and angle EBC, and they also share ray BE. We wouldn't be done there though. There is actually one more pair of adjacent angles, and those would be angle ABD, and angle DBC, right? And they share ray BD. But I'm gonna leave that one out just because we've pretty much filled up all the space. All right, let's keep talking about these. Actually, let me keep the diagram on the board. Let's take a look at letter C. What two angles are complementary? All right, so complementary angles, right, are two angles that sum to 90 degrees. And there's actually only one pair of complementary angles up here. See if you can figure out what they are and name them. Pause the video now. Well, again, complementary angles add up to be a right angle, add up to be a 90-degree angle. And we have two 90-degree angles, right? ABD and DBC. Those are both 90-degree angles. But the DBC is just a single angle, right? There's no other angles in there. This angle, though, ABD, can be broken up into angle ABE and angle EBD or DBE, right? So those are complementary, right? So angle ABE and angle EBD, right? Those two are complementary because they together form a right angle. Now let's look at letter D. What two angles are supplementary? All right, now supplementary angles, when added together, form a straight angle, or 180 degrees. And there's actually two pairs of supplementary angles up here. See if you can name either one of the pairs. Well, perhaps, maybe the most obvious pair are the two 90-degree angles, ABD and DBC, right? Those angles, when put together, ABD and DBC, right, will form the straight angle ABC. All right, so let's write that down. ABD and angle DBC. All right, but there's another pair of supplementary angles, right? This angle, ABE, when combined with this angle, EBC, also would form a straight angle, right? A straight angle. So let's write that one down. Angle ABE and angle EBC. All right, very important to be able to recognize complementary and supplementary angles. Why? Because of what we're going to do in the last part of the problem. All right, I'm going to bring this up a little bit so that we can see the diagram down here and work with it as well. So let's take a look at letter E. If the measure of angle ABE equals 40 degrees, then what is the measure of angle EBD? I'd like you to pause the video right now and think about this a little bit. Draw stuff on the diagram. It'll help. All right, well, ABE is 40 degrees. Let's write that. Okay? Now I want to know EBD. That's this one. All right? But those two angles, ABE and EBD, are complementary. So they must add up. When I add these together, they must add to 90 degrees. So it should make sense that EBD is going to be 90 degrees minus this 40 degrees. So the measure of angle EBD is going to be 90 minus 40, or 50 degrees. All right? Now let's take a look at letter F. If the measure of angle ABE is 40 degrees, then what's the measure of angle CBE? Again, same idea, right? Except now the measure of angle CBE is this angle, right? So pause the video now and think about how you'd find that. Well, this entire angle, right, is a straight angle, 180 degrees. And therefore, 40 degrees of which is taken up by ABE, the other portion of the 180 degrees must be taken up by CBE, and therefore the measure of angle CBE must be 180 minus 40, or 140 degrees. All right, simple enough, as long as you understand some basics. Now let's finally take a look at letter G. If the measure of angle ABE equals 3x plus 2, and the measure of angle EBD equals 4x plus 4, then what is the value of x? Show the work that leads to your answer. All right, so before I have you work on this, I'd like to get rid of that because that is not relevant to this part of the problem. There we go. I'd like you to pause the video and see if you can solve for the value of x. All right, well, one thing that's helpful, if even possible, depending on how big the diagram is that you're working with, is mark these things on the diagram. So the measure of ABE is 3x plus 2. I'm going to write that right down here, right? And the measure of angle EBD, which is this one, is 4x plus 4. And somehow they now want me to figure out what the value of x is. Well, what do I know about those two angles? I know those two angles are complementary, right? I know that this entire angle right here is equal to 90 degrees. It's a quarter turn, right? And that means when I add the measure of this angle to the measure of this angle, I must get the total measure, or 90 degrees. So if I take 3x plus 2 and I add to it 4x plus 4, I must get 90, right? And now we're off to the races, right? No more geometry, now we're just doing some algebra, right? So maybe I'll rearrange this a little bit. So I have 3x plus 4x plus 2 plus 4 is equal to 90, just using a little commutative property of addition there to rearrange a little bit. Of course, now I can combine some like terms, right? 3x plus 4x is 7x. 2 plus 4 is simply 6. Right? I do all of that so that I get my equation into the classic two-step equation solving form. I can now solve my equation by subtracting 6 from both sides. That's going to give me 7x is equal to 84. Now I'm going to divide both sides by 7. If you can't do that in your head, of course, you come over to the side of your sheet and you say, all right, let me put 7 into 84 one time. Subtract 1, 4, 2, 14. Subtract and 0, and therefore x must be equal to 12. All right. Geometry and algebra are often combined, and you never know when you're going to have to set up an equation, all right, in order to actually solve a geometry problem. Or maybe we're setting up an equation based on the geometry in order to solve an algebra problem. I guess it depends on how you look at this. All right, let's wrap this lesson up. So today we saw quite a bit, right? One thing that we saw was how we classify angles, right? And we classify them always relative to quarter turns. An angle that is less than a quarter turn, less than 90 degrees, is an acute angle, sharp. An angle that is exactly 90 degrees is what's called a right angle, and those are critically important, right? All the angles in both rectangles and squares are right angles, so boy are they key, right? And we look for right angles when we see the word perpendicular in a particular geometry problem. Then you've got angles that are larger than 90 degrees but less than 180. Those are what we call obtuse angles. And finally, we have angles exactly equal to 180, straight angles. Then we also talked about angle pairs. Angles that sit right beside each other and share a ray are called adjacent angles. Angles that when put together would form a 90-degree angle are called complementary. And angles that when put together would form a 180-degree angle, a straight angle, are called supplementary. All of these then get wrapped up together in problems that emphasize both geometry and algebra, and we're going to work a lot more with those as we move forward. For now, I just want to thank you for joining me for another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.